Okay, now this leads to the question I just got. But here's the equation. In my notation, that'd be 5 times 2 to the x equals 6. Okay? Now, I'm not going to write out everything here, but it belongs there. I'm just going to do it because the question is about the solution scheme. Okay? If you look at well, I'm looking at number 33, but I'm using my original A's, B's, and C's, okay? But it's there. It's in each set. Okay, this equation. Okay?
What's that, is that a multiplication symbol between the
Yeah.
5 and the 2?
Yeah.
No, down.
It's like a star.
Yeah, it is.
It's an asterisk.
No, yeah.
That's an asterisk.
Okay.
Make my asterisk a little clearer. Okay? So, well, if you follow what you do, you go divide both sides by 5, so you have it in the form 2 to the x equals something, and then you can change it to logarithmic form. So, x is going to be log base 2 of 6/5.
Whoa, now.
And the reason, I'll write out the reason for this step is pretty simple. This is because, what letters do I use? So I can just be literate here. Okay, it's b to the a equals c. Okay, that's how you would write out the reason for this. It's equivalence between the logarithmic and exponential form that we've been talking about for over a week. Okay? And then x is a log of 6/5 divided by the log of 2. Okay? So I'm going to say x is approximately equal to about 1 point, what is it? Let's see, 1.6 or 1.7, ballpark. Okay, take a calculator, work it out. Right? Okay, so that's how you solve the equation. Now we've done those examples of that. Now your calculation scheme and the reason for the question. Okay? You got D equals C over A. E equals the log of D. E with the arrow. F is a log of 2. And X is E over F. There's your calculation scheme. And the question is, what do those extra letters mean? Well, they're just letters that I need. I need 4 letters to do this. Okay? I know a lot of 4-letter words, but I don't think this spells any one of them. Actually, get pretty close. Okay, so you follow the scheme and you should get the same thing you get when you solve the equation. But did you work that one out?
Yeah, but I did not get that, so I don't know if I'm right or you're wrong.
Get your calculator, fix this. Oh, wait a minute. No. Okay. Okay, that's wrong. Let me try again.
Please?
Okay, it's a log of 6/5. That's 0.2. So that's about 0.3.
Okay, yeah, that'll work.
Okay.
Okay. What? Okay, I'm here. F is equal to log what? What is that? I can't see that little parentheses of what?
Log of 2.
A log of 2. Making sure.
You can look at problem 33 and see the scheme. Okay? So I'm just writing it down here. And now we follow the scheme. So the D is going to equal C over A. Well, C is 6, A is 5, so D is 6/5. Now we know that that's an important number, right? But unless we've gone through the solution, we won't necessarily recognize that, right? So, okay, so E is a log of D, and D is 6/5, so E is a log of 6/5, right?
Right.
Could do this, no way. I told you like it.
So when we write it out, our last step is X is E over F. E is a log of 6/5, F is a log of 2, X is log of 6/5 over log of 2, which is of course what we got. Okay? Now this is not how you solve the equation, this is how you can check to see if your solution is correct. Okay? Now, when I say check your solution, I don't mean check it against this calculation scheme. I mean take this number and plug it in for X, see what 2 is to that number, multiply that by 5 and see if you get 6, right? And this is a step that people skip, so people never get immediate feedback on whether they did the equation correctly. Okay? So, what I'm giving you is a scheme to see the answer, but if you read the instructions, it said check your solution. And that means plug your solution into the original equation and see if it works. Okay? So follow the instructions. And then, if you plug this in here and it works, you don't really need to go through this, do you? Okay? Now everybody can do this,
Right.
okay? Because there's only one calculation at a time, and there's no reason for any of them, except basic arithmetic, okay? So doing this calculation scheme is something that I think, you know, everybody seems to be doing their calculations of this nature because they're all very simple. Doesn't mean you don't make a mistake once in a while, okay?
All the time.
You gotta be like me. All right? But you want to be careful with that. You have this as a backup. So if you get this thing all worked out, you think it's all right, and it doesn't work, what do you do? Well, you try to fix it. Okay? Make sense? And if you can't fix it, or at some point, maybe even before you try to fix it, it's up to you how you use this. You do this and you see, oh, here's some important quantities that are going to be involved in solving this. That might give you a hint as to what you messed up. Okay? Make sense? Okay. So hopefully this will be helpful to you. And there might be more stuff like this that I put on the assignment. Okay? Not always with equation solving, but this kind of approach works kind of best with equation solving. Equation solving is real important. Okay? But there might be other applications. I might use this scheme again with some other types of problems. And when I give you equations to solve, I probably do at least some of them with a solution scheme. It doesn't take me long to write out a solution scheme, although I've got to be careful. I don't want to give you a bad one, and I can't guarantee I didn't give you some that don't work. Remember, I told you what to do if it doesn't work. If you do the solution scheme and you plug that number back into the equation and it doesn't work, then either you followed the scheme wrong or I wrote it out wrong. Maybe I typed an X instead of an A, okay? So I tried pretty hard not to have any errors in these, but until you throw them out there, this is a beta version. Errors are going to crop up, if not on this, on something else. You know that. Okay.